Hello everyone, welcome to the EasyPower Tuesday Refresher webinar series. My name is Jim Chastain. I'm an applications engineer here at EasyPower. The purpose of this series is to not necessarily introduce new concepts or technical details, but to amplify features of the tools for tool owners that help them better utilize the tool and hopefully save time on any of their EasyPower projects. To that end, today we're going to be focusing on one-line floor planning, specifically for large projects. It turns out when attacking a large one-line, a different strategy should be employed that really starts before data collection phase of the study. And rather than being rules or even suggestions, this refresher demonstrates a number of techniques that may assist you, including veterans of the tool, ways that can save time in the process. The idea is to make the one line not just more, not just less difficult to navigate, but more useful to people that pick it up after some time has expired and can be able to navigate with the same efficiency as a person most familiar with the study. So what we're going to do is emphasize the understanding of the basics of the tools, suggest that you always want to start small when you're trying out a new technology or a new technique, and then leverage key features to your advantage, understanding them in a small environment, and then go big as far as drawing your one line. And I encourage folks during this process, when they find that they've created an error, or especially for new users, once you've created one line that has errors in it, rather than try to correct it, you may want to consider starting over and realize that that mistake can be propagated if it occurs too early in the process. So as we are apt to do, we'd like to start with some poll questions and appreciate your involvement and participation. The first is, in terms of bus count, how large is a typical one line for you or your organization? So again, no obligation or liability, strictly just trying to get some perspective on how folks are coming to the discussion. And frankly, most of what I'm going to be going through are not elements of my invention. They're actually feedback I've picked up from different EasyPower users over time, and realize that there's some advantages that can be shared without much effort. So it looks like we have a quorum. Here's how folks have weighed in on this. Looks like for the most part we have some fairly large systems that you're wrestling with, and so hopefully this will be a useful topic to get into details. Secondly, do you insert or attach pictures to your one line as you're constructing it, or even later in the life of the one line? Do you attach pictures of the equipment to your one line? And I've actually had people who did data collection virtually all with their cell phone, just capturing images, and they developed a procedure whereby they had the name of the substation, a picture of the front panel, picture of the nameplate, and then likewise down to the switchgear and the motor control centers. And they were able to do that by a regimen that had series and certain arrangement as far as the format, so they could draw their one line just from the pictures that they took, which I thought was pretty clever. Okay, let's see how people have weighed in on this. So again, for those of you that don't, so the downside of attaching pictures is it makes the file much larger. but it's incredible how useful that data can be, especially if you've left the site and have access to the image while you're trying to do the one line back at the office. Just saying, maybe something you want to consider. Yeah, we'll touch on it before I get through. And then finally, which EasyPower features to use more, copy and paste or insert subsystems? And either of these can be utilized, and you'll see where it applies to what I'm trying to explain as far as the procedures. So it looks like we're about to a quorum. Let's leave this open another 10 seconds. Good. So folks have weighed in. So it looks like copy and paste is fairly well utilized. And I'll touch on subsystems briefly, but it may be something we want to take offline if you want to talk about it. Well, thank you for participating. Let's get on to our discussion. So when I talk about starting small, I mean a single utility, a number of substations or transformers for however many different voltage levels you have, one fuse, one relay if your facility uses relays, and then both a multi-K circuit breaker and a low voltage power circuit breaker, and one motor load. And the point being, can you produce the results from that very simple system? So here's a typical one line, in fact, that we use in the workshop. And the point is, I want to go through and be able to verify the results I'm going to achieve. And if I don't have results at any location, and that includes short circuit, equipment duty, sequence of events, and frankly, power flow if you have it. Another reason to have it is that it's a good way to find errors. So first of all, it's amazing how often people report that how effective database browser, the use of database browser, is to locate missing data. And I'm making a note here that if you include under the general options, if you include the loads for panels and MCCs, they will show up in the database browser. And I'll show you what that means in a second. Note that the results you get in short circuit, you want to make sure you have three-phase bolted fault results and single line to ground faults as far as the current for each type of fault. I strongly recommend the use of remote voltage current for a single bus fault, because that tells you a lot about the interconnection and whether or not a fault will cause losses of any particular bus. And again, it's another effective way, one, of finding mistakes, but two, of making sure that you're focusing on the right elements when you're doing the short circuit analysis. And then again, frequently people aren't aware of the sequence of events results report, and they jump right into coordination to start with. So we're going to touch on that. And again, don't be afraid to start over if you have mistakes that occur early, especially if you're still on the simple system. So let me go to EasyPower and let's look at this. So we want to look for the simple.easy. So I want to walk through a couple of these for those of you that, especially if you're new to the tools. Okay, so here's my one-line diagram. When someone sends me a one-line diagram, or even if I've built it myself, the first thing I want to do is look for missing data. And the database browser is the tool to do that. And to utilize it, you go up to database browser. You got the option of checking the database report or the database browser. The browser is very useful in terms of the ability to sort on different fields and look for specific values. And it, as always, it gives us a list of the different generic types of equipment. And for this case, we're looking at low voltage breakers. And what I primarily look for is the short circuit interrupt rating, because this number comes off of the device library datasheet. So if there's not a number here, if there's a number that doesn't make sense, you may want to check your designation of the different elements for that particular part. Both the breakers and the loads, if I look here at motors, I'm only showing one motor. It was a standalone motor. If I have elements in my panels or in my MCCs that I want to include in the database browser report, I'd want to go back to my one line, right-click in an open area, go to Options, and under the General tab, these are workflow decisions. And so what works for you may not be something that works for me. For instance, I very seldom auto-calculate fields for equipment in dialog spreadsheets because I want people, when I'm doing a demo, to see when the calculation is taking place. So once you're used to the tools, you may want to have this checkbox included. The checkbox that I want to focus on is show MCC and panel items in a database report. Without this checked, motors, cables, and breakers that are in the panels and the MCCs won't be shown. So by checking this, now, I've got a panel here that may have something in it. Let's go to our database browser and see if it's changed the count. So now I have 7 breakers versus I think I only had 5 before. And now I show there in the panels. Looks like I only had 3 before. Likewise with cables. Anything that's in the panel will show up. And then my loads. And I don't think, we had 4 loads. And at least one of them, 3 of them are in the panels. So the point is, and I don't have anything entered for them, so it's something I may want to work on or evaluate before I get too much further along. So the point is, it's a good way to find missing data. You can look at all columns, which is, I think there's 30 some odd columns of data. You can sort for specific types of equipment. And again, another point that I check are the breakers to make sure I've got short circuit interrupt rating, and I can see here I've got 3 of them that haven't been properly designated. Okay, so make sure you have no missing data and you have the facility to confidently look for it. The question about pictures in every element that has a dialog box, which is virtually everything in the one line. Once I open the dialog box, for instance, for the transformer, you'll notice that all the dialog boxes have the same general format: unique identifier, the connection point in the systems, and a number of tabs. What I mean as far as the ID name has to be unique for that generic type of equipment. And so if you have a very large plant, you may need to come up with a unique labeling system that gives you some designation either to the load or the substation or somehow or another that identifies this part and can be found easier, frankly, even with the database browser sorting for that particular subsection. But every element box or every dialog box has this little icon over here called collected data. And within that, there's the ability to take pictures or store pictures that you've captured on a camera or some other. Let me see if I can find one. Well, I'm not finding my picture. Give me another second. Usually they're called Acme pictures, and I don't see anyone. Well, if I had a picture, I would be able to capture it and associate it with this particular element in the database. Well, I'm going to use my Alfred E. Newman picture. So once I took a picture of the nameplate, I can associate it with this element, and it'll be there in my with the project for posterity to look at and be able to go back and refer to. So I strongly suggest, because this can be pictures that are taken with a digital camera and they can be taken at the same time I'm drawing the one-line diagram by just clicking on the camera, and it'll time sync with the date codes that the camera takes on the images. So it's a very useful feature, especially if you're working on, if you want to keep images with the project. So now once I've got my data complete, I want to go to short circuit focus, fault all the buses. Right now I'm looking at a three-phase bolted fault. I can see no escapes as far as missing data. I can see A, B, and C phases without a problem. I can see momentary, interrupting, and 30 cycle currents. I can see motor contribution. And single phase and three-phase faults. The other thing I want to point out is the equipment duty. So very much not to be overlooked is comparing the number, which is the total available fault current, with the rating for that element, which was captured during the short circuit analysis. So if I go to equipment duty, I'm looking for red escapes, and I see here one, the fuse is showing up with a red number, but there with a red icon and no number, which means there's not a data in the location where the equipment duty test is being made. So I need to fix that before I go further. And again, my reports would include equipment duty report, and this would uncover issues before I even get started with my layout. Okay, so I'm getting the data that I expect, and without worrying about whether or not they're accurate or not, I can get my arc flash results. So I'm getting numbers at least all over the place. So for a simple diagram, this looks to be filling the bill. Sequence of events. When I go to coordination, looking at current, up here I'm going to look at a half cycle bolted fault, pick out a single downstream bus. So a single bus and fault it. The tool will show me this icon here called sequence of events. And if I click on that, now instead of current, it shows me the chronological trip time of every upstream device between the fault location and the energy source. So if this bus faults, this breaker will trip in 10 milliseconds. This fuse isn't tripping because we don't have it set up correctly. This fuse is tripping in 7 seconds. This main breaker will trip in 59 seconds, and the main fuse will trip in 218 seconds. So I have a sequence of events look like it's working okay. If I go to PDC options, bottom right-hand column, create a sequence of events, and then fault that bus again. Again, I want to make sure I can do this. I can generate this report in a basic system before I get too large and have to go back and retrace my steps. So without a warning or an error, I've got verification that I have sequence of events proper for that particular load. Okay, so all of those steps should be something that you're able to perform before you start generating your one-line diagram on a large scale. So if any of that is not known to you, I'd encourage you to look on the website for webinars or videos that we have for each of those steps, or contact tech support and say, hey, Jim said I could do such and such, and I don't find it. Okay, now, as far as large systems, no isolated systems are allowed. And so one way to build a large system is to have multiple one-lines that you've collected and built simultaneously or individually. And then at the end of the day, you want to connect them. And the recommended procedure is to use a virtual connection. This can be a cable or a busway. And what it amounts to, you're going to create a connection that doesn't really ever exist. And so the switch on that virtual connection will be locked open. So it really doesn't matter what sizing is or what the rating is, because it's never going to see current. So again, here's how this looks in EasyPower. You can't see what? This second. Cut off the menus to the side. Okay, there's a question. You can't find the database browser. Okay, the database browser, let me open up. Now we're on the right. One person couldn't see my whole screen. You can zoom out. You can zoom in and out with the roller wheel and go to meeting, go to webinar on the screen. Let me open up the next file and talk about what to look at. So the question was, you couldn't find database browser. I'm using 11.0, and the database browser is on the top focus. For 10.3 or 10.6 and earlier, you have to go to File, and Database Browser will be under the file listing. It's not quite, the older version of Database Browser is not as user-friendly or as versatile, but it still shows the same information. It just can't be manipulated quite as much. Okay, so what I've done here is basically start with my one line, and on successive days, I've collected data and then drawn the one line. And on the second day, I've got a system over here that I've copied and pasted now into this first system, and I'm going to activate it. And what I'm talking about as far as a virtual connection is this busway that I've created here. We open it up, I label it a virtual busway. Doesn't matter what size or capacity is, so I'm just going with generic values, and I'm going to have it as a dotted line so we can tell the difference. And then I'm going to put a switch in it right here. And again, the switch is never going to carry any capacity, so it doesn't matter what the manufacturer is or the ampacity is, but we're always going to leave it open. And so by doing that, and I'm connecting the same voltage relay, so I'm not having to go through a transformer. So I'm connecting the 12.8 utility to the 12.8 utility. What this allows are different utility connections with different utility data. So in this case, this utility connection is 22,000 amps. Over here, we've only got 15,000 amps. And for some reason, well, and the systems are in the same location, but they're not physically connected. And we can do the same thing with the third building. Let's say we have over here, I can copy and paste it into my one line. I'm going to activate it. And here, I don't have a 12.8 kV. I've got a 480 volt bus. So I'm going to use a cable, virtual cable, to connect here. And again, it doesn't, as long as it's touching the bus, it doesn't have to be connected. We're going to put a basic switch. As long as I got the same voltage, I'm going to characterize the switch as always open. We call it virtual. Again, these are techniques to utilize. In other words, you don't have to do it this way, but it seems to be expedient in solving a problem of getting everything on the same one line with generic values, because they're never going to see actual use. So again, I want to pick up typical. Now, once I've done that, now I can go back, and now I can hide this if I want to. So if I don't want to show the entire line for this cable, I stub it off, and now it's a virtual. So I work out some kind of scheme as far as labeling that. Now with this done, I can go to short circuit focus. I can fault all the buses. And now I get independent results from each of these systems, in spite of the fact that I have them connected together with these virtual buses, virtual connectors. And so now, just to check out my equipment duty report, looks like I don't have anything exceeding my ratings. Yeah. And then likewise for coordination. Now, here we go into coordination, and we look at individual bus, fault it, and then look at sequence of events. And since I don't have any protective devices up there, nothing's going to show up. Okay, so where did my questions go? There it is. So any questions about the virtual connection? It's a clever construct. There's no recommendation necessarily to use it. It's something that you can use in your own system. So Stephen's going, why don't we just do isolated systems? Well, that's you can make that a feature request email into tech support. Okay, finally, so Again, that's above my pay grade as far as just doing it. But I suspect you don't have a full appreciation for what it takes to do the analysis at a reasonable. So I'm going to close this, and I'm going to go to a larger project that I've actually saved. Let's see here. So the whole thing is there's no isolated systems allowed. So if you can't connect things together, literally, physically, now obviously many systems we can, and for those systems which are interconnected with tie breakers and crossovers, you do have to come up with some name if you're going to be cutting and pasting for keeping the names unique in the ID name box, because copy and paste will start repeating labels if you haven't entered them as an alternative. Okay, so now is a problem where if you want to have much larger campus, for instance, there's multiple ways to do this, and being able to jump around in a large one line is a feature we called named view. So get used to it, get used to how to utilize it, and in some of these practice sessions, it's a good thing to play with. But let me show you what it looks like. And I inherited this, or I borrowed this from a facility group in University of Wyoming, I believe. But they had a very complex system that included a ring bus. And so what they did is they built their one line and created these frames of the same size that they know is going to create a drawing for their purpose. And if they go to named view under control, easy control, there's a feature down here called named views. And by assigning names, you can save the pan and zoom features. For instance, here's the ring bus, and this is still on the same one line. We just zoomed and panned into it where it's center of the screen. If I can go back to the main one line and zoom back into the ringed view under named views, nothing's physically changed in the one line itself. So they built their one line with two connections into the utility of their ring bus, and the interconnects are all there that can be isolated or disconnected if they have to boot around or do temporary patching. But then they want to have each of the buildings be reflected in their own frame down below. And so this creates the substation frame. Again, we're still on the main one line, but now we're focused on the section which is the substation. Now, if I wanted to save a drawing of this substation, I could create it and save it under drawings. And now I could print it out with its own analysis. So let's go back to name views. All right, so the idea is to be able to create at least the transformer, the step-down transformer for my building, in which case I'm going to left-click and drag the subsection that I've already started. Now I want to drag or expand on a cable or a busway. So this is a cable that goes from the ring bus down to the step-down transformer for the mailer hall. So I'm going to left-click and drag and do it on the cable itself. Put it in mailer hall. And then I'm going to open up the dialog box for the cable that I expanded. And now I'm going to stub it off by saying don't show the entire line. And by doing that, now I have my mailer hall substation. And if I want, I could do things like add a schedule. So I select the panel, insert a schedule, or any number of schedules. And then once I've got this arranged, I would create a new named view. Let's pin it out here. Create a new named view. Call it mailer. Which I already had, but I'm going to redo it. Now I can, cyclers, navigate to any part of my one line and things are all connected. And now I can go into short circuit focus if I have things properly populated. Let's say I just want to calculate for this new building. I'd left click and select it, fault all the buses. Now I'm looking at the half cycle current for a 3-phase bolted fault. I can see my equipment duty. Looks like I have issues on my panel and my breakers. I can go into coordination. I can work on coordination. I can do power flow if I don't have any warnings. So this is unbalanced power flow. Okay, so the point to be made is I have a very complex system. I have the ability now to navigate it with a one button click and don't have to scroll and pan all over the place. I can create drawings and then create the analytical results, the test results from the drawing and print it out. Okay, so do we have any questions? So verify the procedure that you want to use on a small scale, and rather than carry mistakes into large projects, start from scratch once you have something that works. Remember, you can't have isolated systems because it will give you issues. And think in terms of someone trying to use your one line where you're not around, or if you've not dealt with it in the last 30 days. I do have a couple of announcements before we go back and look at the questions. The situation, for instance, is incident energy calculated on a low voltage panel is high, so because we've excluded the main on the panel. So the engineers applied a 2-second rule to be a more realistic value on the label, but now the spreadsheet shows manual time. However, the client wants the label to show the actual upstream breaker protecting this panel. How do you get that? Well, the answer is a custom label. And this question, this situation, prompted a webinar that we're going to hold or we're going to go through in 2 weeks. So if you haven't cut your teeth on the label maker, this is a good situation to do so. I also wanted to remind folks that all new EasyPower users are offered a no-cost 1-hour online feature orientation to help you get up and running as soon as possible. And this applies to all new employees of company who has current maintenance. So just ask for a power start. Say, hey, Jim said I could get a power start. How do I do it? Send that email to sales or to me, and we'll take care of it. Most people find it an hour well spent. So let's see if we got any other questions. The purpose of the virtual connection. Okay. Um, this is it's a good question. What it amounts to, and you don't know it until you run into it. But if you have if you have two buildings that are isolated systems, but you want them on the same one line, the tool will not let you do that. In other words, if I go back to let me go back to the other example. It'll throw errors is what it boils down to. And so if I close this is all connected, and so there's no need for virtual connections on my campus. However, on any one of these other systems that I've built, if I try to run, so here I'm going to activate this other system that I copy and pasted. I'm going to delete this connection. Now, if I try to go to short circuit focus, it's going to say, hey, there's problems, isolated systems were found. And if I view the report, it's going to say, hey, this is not connected to this. And so that's the purpose of the virtual connection. If you don't have isolated systems, then you don't need to worry about it. How do you print the name view? You got to make it a drawing. So that's the purpose of building the little frames, is that I knew that once I fit it into the frame, I could generate a drawing from that frame. How do you create a box that fits on standard printed paper? Trial and error. That's exactly what I did for my I forget which example I used, but I just trial and error printing a frame on the box and then seeing how it fits on I'll go back and try that. Before diving into large projects, what are sequence of checks we need to perform? Homer, that's essentially what I walked through. Make sure you can do a short circuit analysis and get results on each bus. Make sure you can do equipment duty results. And then make sure you have a sequence of events, capability, and all that tells you, and frankly, power flow. By going through those 4 steps, you don't have to debug it. You just have to make sure you're getting results. Then you know that your debug time will be productive or not wasted trying to fix bugs. Okay, so the only other thing that seems like I had was a question about trial and error. Let me just, I'm looking at the way I did the campus setup. Let's go to start page, pick up my campus. So Homer, you were asking how we know it's going to fit. I drew this frame. Zoom in on it. Left click and drag. Now I create a new drawing. And it tells me I'm close but no cigar. So I may want to make the frame, which is the rust color, slightly smaller so it'll fit exactly in my by 11 by 17. Make sense? Okay, that's all I got. You're more than welcome to contact me via email, or especially if you want to talk about any of these topics or if you want a power start. Have a good day. We'll talk to you all in 2 weeks.